start week 13, and what are we starting with? We're gonna start with the instructions. So what do they look like? Here's the instructions. This is your last homework assignment you have to hand in for the semester. Oh my God, is that unbelievable? And sure enough, you have a written assignment and you have an Excel assignment. So just two parts. Due Monday, 2 p.m., April 14th. You got a whole week. The usual materials, slides 16 to 38, textbook pages, Excel spreadsheets. Last day to hand in older late submissions. So any older late submissions. Look back and see if you've got any zeros. You have only until, what's the last date? Monday, April 14th. A week from today is all you have to get in if you have any zeros. Just, the answers are posted, so get those in. There's no reason not to. Just put it in your own handwriting. Unless it's an Excel spreadsheet that was handed in as an Excel spreadsheet, then you can hand it in late as an Excel spreadsheet. Any questions about that? What about final exam? Let me go back right here. Let's see. We have a lecture today, lecture Wednesday, lecture Monday, April 14th. Then Wednesday on the April 16th at 2 o'clock, you have part 1 of your exam, which will be around 40-minute time limit. Then on Monday, 5 days later, on April 21st, you have part 2 at 3 o'clock, not 2 o'clock, 3 o'clock in this room, more like an hour time limit, part 2. So does everybody know what to expect? Both of them are cumulative, meaning anything from the whole semester can be on there except on part 1, there's a lecture 2 days before it. Anything from that day's lecture will not be on part 1. Part 1 will already be written and photocopied before that lecture. So it won't be on part 1, but anything else can be on there other than that lecture. And part 2 can have anything, including that lecture. So you know the whole thing. But keep in mind, I've given you lots of hints, including that when I'm digging up questions from old material, remember the first section from quiz 1 was all confidence intervals. The second section that was based around quiz 2 was 1 sample hypothesis testing. The third section was 2 sample hypothesis testing. So going back to section 1 and 2, I'm probably going to be picking questions that are highlighting the most important parts of those sections, those 3 weeks and those other 3 weeks. The most important parts. I'm not trying to go into some obscure part of those. I'm going back to some important parts. So you should have a fair idea what to expect on the both parts of the final exam. I write them just like the quizzes, so you can, some of you should be able to slightly predict what I'm probably going to be putting on there, what the multiple choice questions look like. I already gave you hints that some of the multiple choice questions will be where you're reading a problem and just telling me which equation you would use to solve it, A, B, C, D, or E. Just recognizing what kind of problem it is good. And then you have the problems where you got to recognize the problem is. So that's what I said. The number 1 way to study to prepare for the exam is being able to recognize any problem from any homework assignment the whole semester. That'd be the number 1 way to study, because that's the number 1 tool or objective that you have in front of you while you're taking it, is recognizing the problem you have. So that's all we got left, and this semester's over, and I'm on permanent vacation after I hand in grades. You know how long it's going to take me to grade all this stuff? Till April 30th. Anyways, I don't know what that means.
That's when grades are due?
Yeah, I think so.
Yeah.
That's when I'm planning on handing in. Now, I want you to notice something about the written assignment. Where is it? Did I open it up? There it is. Out of the book. Out of the book. But to make things easy, I posted this right here. Let me just scroll for you here. There's number 12. There's number 13. There's number 14. 15, 16, 17, 18. I think I went all the way, the whole homework. 19, 19, 20, 21. It should be 22 also. Let me keep going. And 22. So there's everything you need to do the written part of your homework. What's crazy is it looks like there's a lot of problems, but each problem is going to take you about 2 minutes, because I believe they're all forecasting problems. After today's lecture, you could do the whole written assignment probably in 10 minutes, 15 minutes at the most, and have that part done. And probably most of the Excel part too. So it's not that hard. If you notice, like, just to give you a quick example, on let me get to the beginning here. Number 12, let me go back to the assignment. It says 12A, you're only doing part A. So there's only one question from part 12. So let me look at it. And it says, in a simple linear regression, the following sample regression equations obtained. Y with a hat over it stands for forecast, so it probably is gonna ask for the forecast. Equals 15. That number right there, that first number, that's your intercept. Forecast equals intercept plus slope times whatever x is gonna be. And then it says 2.5 is your slope times x. A says predict y if x equals 10. You put 10 in for x and do the math. Now, let me help you make sure you don't make a mistake here. Order of operations says you gotta do that multiplication before you add. Don't add before you multiply. That could be the only crazy mistake you might make. Multiply, add, number 12 is done. Took you 1.5 minutes, boom. Then go to the next one, the next one. Each one of them are that easy, pretty much. All right? Again, forecast equals intercept plus slope times x. Where we're heading today, though, is multi-linear regression. And the formula is almost the same. Forecast equals intercept's gonna be a number, then plus slope 1 times x1. You'll be told what x1 is, and you'll be able to see what slope 1 is. Plus slope 2 times x2, dot, dot, dot. However many explanatory variables you have, each x is the explanatory variable, explains things. And the y is your, lost my train of thought. Explanatory and the one that gets explained, whatever that is, I forgot. You gotta go back here, let's take a look. Boom, good time to open this up so I can remember the word I'm looking for. Response, thank you, there it is. Explanatory variable is every one of the x's, and your response variable is the y. The one that's being affected by the x's. Don't get me wrong, you can use this formula both ways. The milk example I gave you is, hey, I know I want to sell a certain amount of milk, so I can work it backwards to figure out what price to set it at to try to increase my probability of selling that much milk. You know, you can work it either way with algebra, but in most cases, you're always given the x, which is the explanatory variable, and you're supposed to come up with the response by plugging in the numbers. Now, I want to, let me look, make sure I'm not skipping anything. The other part of your assignment, that's right, I'll show you this. Week 13, regression, right here. This part of your assignment is where you have almost the same data. It may even be the exact same data. Every month, 15 months worth of data, sales through month 1 through 15. But this time, you're not gonna form your columns. You're not gonna do it manually. You're gonna use data analysis, the regression model to solve it. And we're gonna learn how to read the output and find the slope and intercept from the output and then do our forecast. And I want you to forecast, let's see, month 20, 21, 22, and 23 by using the cell locations where the slope and the intercept are, wherever it is you're gonna place your output. So you need to place your output anywhere in the blank area. Let me scroll down. Anyone over here. So once you do your data analysis, and I'll show you how to do it, place it anywhere over here, and then you're gonna use wherever that slope and intercept lands, in whatever cell location, that's what you use to answer these 4 forecasts, the cell locations where that intercept and slope is. There's that part of the homework. That's all it's due. Those homework problems out of the book and this spreadsheet. And that's all it's due a week from today, and then you have no more homework from this class from that point on. You can get this done tonight and have no more homework in this class. You'll be done with this class. I don't even know why you're showing up. Just kidding.
Participation.
Oh, there you go. That's a good reading. Let's recall the formulas again. There is, again, the forecasting formula we just talked about, but this one is if there's only one explanatory variable. Again, B1 is the slope on all of these things you're reading. I use the word slope, but B1's the slope. X is the explanatory variable. B sub O is your intercept on all of these. I just use the word intercept, but B sub O you're gonna see a bunch of times is your intercept. And then the response variable Y is your, in this case, we're trying to forecast the response variable, forecasting. Now, here's, what's the other formula I wanted to review here? This one right here. I want to refresh your memory. This is the slope formula. If you're being asked to do it manually, this is how you do it. You form your columns. X minus the mean of X would be the next column. Then the next one after that would be Y minus the mean of Y. then the column of that next to that would be these two columns multiplied by each other. And then, this is the column we didn't do, right here. X minus the mean of x squared. Oh, we did do that one, I'm sorry. That was the denominator. The sum of that column is your denominator. Then you get your slope. You plug your slope in to find your intercept. You gotta use the mean of x, the mean of y, and the slope you just calculated. Now here's what I wanna point out. Here's where everybody makes the mistake. If you got, let's say you're given, on the final exam, you might be given certain information. Matter of fact, you may be given 3 parts of this formula where all you gotta do is plug them in and find this slope. Everybody hear that? You don't have to calculate the sum of x minus the mean of x. Maybe you're given that. You don't have to calculate the, or the sum of x minus the mean of x squared. Maybe you're given that. But you still gotta find the slope. Then you're gonna use that slope because you're also given the mean of y and mean of x to find the intercept. Here's what I wanna point out. I wanna make sure everybody hears this. The formula to find the intercept is using a subtraction, subtracting the slope. But the formula for the forecast is adding the slope. Many people will accidentally add both of these formulas, have a plus in the middle instead of subtraction. Let me repeat that. To find the intercept, it's a subtraction, but you use the intercept to find the forecast, but it's a plus, not a subtraction, it's an add. Now be careful because your slope could be a negative. So if you're doing a forecast, it would be adding a negative slope, which would end up really be subtracting. And let me go down here. This is subtraction here, but if your slope's a negative, you'd be adding to find the intercept because it's a subtraction. Everybody get what I'm saying? So I want you to be extra careful on this. This is the #1 mistake on this part. Okay, now that we have all that, I want to go to SSE. Here's SSE right here. It says, take your real y, your response variables, compare it to what they would have been if you were forecasting them, and then square it, that result, and then add them up, and this is called your standard sum error. The standard sum error is one of the errors that we're gonna learn in this class. We have one more that we're learning on Wednesday, 2 more maybe. And the rule of thumb is on all these error calculations, is whichever error calculation gives you the lowest result is the one you wanna use for your forecast. It fits the data the best. Let me repeat that. If we're using SSE, whichever forecasting technique gives you the lowest SSE, that's the technique fitting the data the best, and that's the one you wanna use. If we're using a 3-period average forecasting model, use it and calculate your SSE on that one, and compare it to the SSE using regression. And whichever one gives you the lowest SSE, that's the model you should be using to do your forecast. We just happen to only be learning one forecasting model right now. We have another one coming. All right, so now that I said all that, I want to do SSE. This is from last week. Last week we did all these forecasts, or we did all this x minus the mean of x, y minus the mean of y, blah, blah, blah. We got our slope and intercept. Slope was 1.25. That was our slope we calculated last week. And then we calculated the intercept as 2. The mean of x is 4, the mean of y is 7. There's the numbers we know. Now, how do you use SSE? You use SSE by plugging in for x the real x's, the x's that you already have y's for. And you see how far off the forecast would be from the actual. So look at the first x. The real x, we could forecast the future and say, oh, let's use 1 and do a forecast, but no. When we're trying to see how the fit is, we want to use actual x's. So I'm going to start at the top. I'm plugging 6 in. You ready? Hang on, I want to make sure the camera can see everything. So 2 plus 1.2, somebody get a calculator out, times 6. 6 times 1.25, let's see, that's going to be, that's 6, 7, 7.5? Is that 7.5? 1.25 times 6, 7.5, I'm guessing?
Why are you writing divided though?
What's going on?
1.25.
No, that's a, there you go. There you go. How's that? 1.25 times 6, so you get 7.5. 7.5 plus 2 equals 9. Is it 9 or 9.5? 9.5? Anybody else got, anybody, come on you guys, I need at least 2 people.
6 is 7.5.
Plus 2 makes 9.5, so watch. I'm putting a Y with a hat over it, which stands for forecast. And so when we put 6 in, we get 9.5. What's the difference? Here we go, y minus the forecast y equals 0.5. Next, y minus the forecast of y squared equals 0.5 times 0.5 is 0.25, right? Everybody still with me? You know what? I think I have this on a piece of paper, so I don't need to keep bothering you. Here we go, next one. Now we have an actual 4. So here we go, I'm plugging in 4 now. 4 times 1.25 is 5, is that right? 5? 5 plus 2 makes 7. So our forecasting model forecasts 7 for y when it's a 4, but the actual number for y was a 6. 6 minus 7 is -1. -1 squared is a 1. You see where I'm going with this? It's not that hard. Here we go. Now I'm going to plug in the last actual x we have to compare, which is a 2. So I'm putting a 2 in. 2 times 1.5 is 2.5. Is that right? 2.5 plus 2 makes 4.5. The actual was a 5. 4.5 is our forecast. 5 minus 4.5 is 0.5 is the difference. 0.5 squared is 0.25. Now, the last step, if you see in the formula here, I want to review this formula. Y minus the forecast of y squared, sum of. We add that last column up. Each one of those y's minus the forecast squared up. 0.25 plus 0.25 is 0.5 plus 1 is 1.5. That is our SSE for that one. Now, we would do this again with a different forecasting formula. We would use whatever forecasting formula it is. We would get 3 forecasts, we would compare it to these actuals, and we would get an SSE for that one. And whichever one gives us the lowest SSE is the better fitting forecasting technique right now. And that's the one we'll do for the next 3 months for our forecasts, or the next year, whatever our usual forecasts are. And then after that, we reevaluate. We have it all in Excel spreadsheets. So all it takes is just changing a couple numbers, and we reevaluate both techniques or 3 different techniques again. And sometimes the technique changes as to a better fit, and you'll use then a different technique for the next 3 months or 4 months for all your forecasts. And this is an ongoing process. So does everybody see how I calculated SSE? All right, there we go. We're caught up. So now, where are we going here? I want to demo this. Let me show up the right one. F24. Whoops, where is it? Right there. Here's an example now of, let me make sure I got this right, of using, you did it manually, and you got your slope and your intercept, okay? And now I'm asking you to do your forecast. So I want you to look at this spreadsheet. Remember the formula. Right now, this spreadsheet only has 1 explanatory variable, so we're only going 1 deep here. The forecast equals the intercept plus slope times x. The only thing that's going to change on all these forecasts we're about to do is x. So when we're writing our equation, cell location equation on Excel to do the forecast, we can use the dollar signs in front of the cell locations, letter and number, because we don't want that to switch where the slope and intercept is, only x. So here we go. I'm going to scroll over here. Whoops, I'm over as far as I can. Everything you can see where we're at right here. And here's our slope and intercept. So look at, I did the first one right here. Our data goes up to month 15, and we're at, let's say 15 is this month. And we want to do a forecast of sales for next month, the month after, and the month after. And that happens to be month 16, 17, and 18 as it relates to the data that we're using for this slope and this intercept. So however it relates to that data is month 16, 17, 18. So here we go. Wait, before I click on this, is it already up there? No. Does anybody think they can tell me? I want to make sure all the cell locations are there. Look at all the cell locations. I know it's kind of small. What would be, to get that forecast for month 16, what do you think is in there? Equals, where's the intercept? Say the cell? Is that what it is? It is B26, you're right. B26, watch what I'm doing. $B, $26. The formula says to forecast add, not subtract, add, now the slope. B25, it's just that easy. Dollar sign B, dollar sign 25. Now you gotta give the star, asterisk, times, and then now what? Would I take off points if you just put 16 here? Probably not. But I'd like for you to use cell location, so let's use the cell location where 16's at. Right there, where my pointer's at. What is that, B30? And this we have no dollar signs, B30. So I can copy and paste this for month 17, for month 18, for month 19, for month 20, because this cell, B30, will go to B31, B32, B33, but the intercept and slope won't change. So sure enough, that is what's here. Let me click on it. Dollar sign B, dollar sign 26, plus dollar sign B, dollar sign 25, asterisk, B30. Now when I copy and paste this, first of all, look at the direction, look at the actual data, look at our forecast. Will month 17, or look at our slope even, will month 17 be a larger number or smaller number than the 1,302,000 that's in month 16? Larger or smaller in month 17? I heard it. Larger it is. Month 18, larger or smaller? It has to be larger because our slope is a positive number. Our slope is 28,408. So each month forecast is going to be 28,408 more, larger. Matter of fact, you can tell me what the next forecast is. Just add 28,408 to this. 302,000 plus 28,000 makes about 330,000, maybe 331. Here we go. 330. 1,330,447. So you tell me what's the next forecast then? 1,300,000 and what thousand? I heard it. 58. So here we go. If this is doing it right, it should be 58. 1,358,000, blah, blah, blah. There it is. All right. There is how you would do it using manually. If you did all your calculations and manually got your slope. The whole point is that you got to find that slope and that intercept. Now, let's go here. Whoops. Hang on. Now, in this case, we don't have all the columns. We have our explanatory variable, this time is only 12 months. We have our response variable, 12 months. Look at the direction. As our x is going up, what is happening to our y? Going up or down? Down. Correlation, the correlation number will be positive or negative? Negative, because they're going opposite directions. Exactly. But here's what we're going to use. We're going to go to the data tab. We're going to go to data analysis. We're going to select regression. Then it says input the response variable for the y, input the explanatory variable range for the x, select the box for labels, select the output range. This time we need it here. We need it on this worksheet. We don't want it on a new worksheet because we got to refer to the cell locations where the intercept and the slope lands. Before I do that, I want to show you one. Here's what it's going to look like when it comes up, by the way, right there. Notice we're only checking that labels box. We're not doing these other boxes, just the labels. And we're not going to do, whoop, didn't mean to do that. We're not doing new worksheet either. Oh, I ruined that slide over here. There, let's look at this output. All right, tell me the intercept. Is it blurry? 210.2977. There's the intercept. Tell me the slope. This is hard, isn't it?
10.44.
It is. The slope, though, is labeled as income because income must have been our explanatory variable. Let me go back and look. Let debt income, let income be one and payments be the other. This is using R. But there it is, right there. Now where we're heading is if we have two explanatory variables. Whatever the name of those two explanatory variables will be underneath the intercept, and the slopes will be next to each explanatory variable. Even if they're labeled X, it will say X1 will have a slope, X2 will have a slope. So here we go, we're doing this one. Now before I do this one, right here, this example, is this the example? I want to make sure you realize this is almost exactly what you're doing for your homework. So I'm gonna open this up right now and I hope the data is not already in there. I bet it is. Find regression. There's regression right there. Regression, click OK. Ah, good, nothing there. I start by clicking on labels. Now make sure your first reaction is, hey, I thought to myself, I'm gonna put my X data right there. But it specifically says, input your Y range of data, your response variable, not your explanatory. So I'm jumping over here, right there, the label's gonna be Y. I'm left clicking on that Y, holding down my left click, and going all the way down to include all the data. So it went in as $E, $7 to E19. E7 to E19, including the label Y. Now I'm going to X. I clicked in the box, left click where the X is in C7, hold it down, scroll down to get all the data, let go. There it is, C7 to C19. I already clicked labels. New worksheet, no. Output range. Output range, where do I want it? I gotta move this box, move that over. I think I'm gonna put it right here. Uh-oh, what's the deal? Oh, I gotta click here first. Click here, now tell you where I want it. I want it right there. In fact, I'm gonna go like this. There, how's that? So that I'm just telling where it wants to start. The left corner will line up right there. I could have just clicked on one box and the whole table then will be from there and that will be the left corner. But I just did some more cells just because. So when I click OK, my first question is, what's the intercept? Oops, let me scroll down. That's right. Anybody else see it? What's the intercept? 30.848. But what's more important is, what's the cell location? This is the hard part. Can I make this bigger? Let me see what happens. Okay, now where's the cell location? L31, right there. L31. So our formula, look at, we're trying to forecast period 13, 14, 15. I'm going to go right here. I'm going to start my formula. Equal, what was it? L31? Dollar sign L, dollar sign 31. Is it plus or minus on forecast? Plus. Okay, where's the slope? What's the slope? How about that? What's the slope? X, that's right. Negative 0.68, blah, 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 blah. It's a negative, but we put plus because the formula says to put plus. When I put the cell location, it's going to recognize that's a negative number and it will subtract. So the cell location right there is L32. So dollar sign L, dollar sign L, dollar sign 32. And then what's X? Times cell location for X. C24, there it is with no dollar signs. C24. When I copy and paste that, the next one will be C25. Copy and paste it, the next one will be C26. Here I go. What should my forecast be? Now look at our previous data. 25, 24, 23. That was when X is 10, 11, and 12. Now it's 13. Should our next one be lower or greater than 23? Lower than 23. Lower by about 0.68. So we're looking at maybe, I don't know. It's going to start at 30, then 13 times 0.68 minus, so we're looking at maybe 20 or 21. Here we go. 21.98. Okay, now the other ones are easy to predict because the only thing that affects the next one is the slope only. So the next one is going to be 0.68 less. So if we're subtracting 0.68 from this, because now it's 14 times negative 0.68, we're going to get 21.3. Does that sound right? Here we go. Copy, paste, 21.3. Now we're going to subtract another 0.68 from this one. So our forecast for the next period, 15, should be just 0.68 less, which is going to be 7? No, 6, 6.2, 6.4, something? I don't know. Let's take a look. 6.2. 20.62. Did everybody see how I did this? That's your homework assignment. How long did that take? And I was taking my time. Not very long. Oh my God, we can have this homework done tonight, you mean, and never have any more homework in this class for the rest of the semester, which is only a week and a half longer to go anyway? Oh. Who brought the pizza? Just checking. All right, I gotta get this off of here. I gotta erase this again, gotta figure out what to do here. That's not working. Okay, back up. Whoop. Back up. What's going on? It will not get rid of the table. I gotta be careful, what do I get rid of? Alright, let me just clear this off real quick. Okay. Okay, well now we gotta talk about multiple regression. Having more than one exploratory variable. I'm never gonna remember to get rid of this. So let's get rid of it right now. Keep going. I believe there's this much on the output here. All right. Multilinear regression. This is having more than one exploratory variable. That will explain the response variable. They can each have an effect. So you would just go on and on and on. You could have, every x could have a slope with it going on. You have an initial intercept, and then the first explanatory variable with its slope, the second one, and so on, however many there are. Looks like this. So, you ready? Here is an example where you have, whoops, I need to get rid of this. Let's create a new table. That's going to get rid of, let's create a whole new table. We have two x's, x1 and x2. Oh. See if it'll go right on top of it, what's left there. Alright? And you're saying, and when you go data analysis, let me go data. Let me go data analysis. Let's hope the numbers aren't in there. Let's go regression, will be. I already did it. So let me get that out. Stop looking at them. Let me get them out of there. Whoops. There. Right there. Okay, let me get this one out. Right there. Here we go. Now, looks just like regular regression. The box doesn't change at all. Here's the difference. Because we have two explanatory variables or three explanatory variables, and we're going to include their labels, by highlighting all the explanatory variables at once, the labels will distinguish that you have more than one. Excel will know right away that there's more than one there, and it will calculate the slope for each one individually. So here we go. I'm going with the input range for X down here. I'll do Y first. Here's the response variable. I clicked on labels. Here it is. From G7 to G19. But here's the weird part. Explanatory X. There's more than one variable. I clicked on labels. I'm left clicking where the first label is, but watch. I'm going over to the second label, then down. I'm doing both of them at the same time. And if there were three, I'd be going over to the third one over there. The deal is, though, that the explanatory data have to be in columns next to each other to be able to do this. So you just got them all at one time. Look at what's here. C7 all the way through D19. It's using two different columns, two different variables there. It will know that these are two different ones, and it will give us two slopes, one for X1 and one for X2. Where do we want the output range? We don't want it on a new worksheet. We want it right here where our data is. I clicked on it. Let me move this over. I'm going to click on it again. I'm going to put it right here. I'm going to hope that it writes over this old stuff over here. It may even say about to write over some old stuff, and I'll say, yes, go ahead. Let's hope it works. So here we go now. We should have two slopes if we did this right. It says I'm going to write over, yes, right over it. There we go. All right, it worked. Let me scroll up, scroll up. What's the intercept? 28.57, let's say. What's the slope of the first variable? Negative 0.516. The slope of the second variable is positive 0.18. I'm rounding, 0.179, whatever. Everybody see it? Now we gotta write these forecasting formulas. Hang on. Let me get rid of this. Let me get rid of this one. Let me get rid of this one. There we go. Here we go. It says we want 3 forecasts. We want to know if x1 is 13 and x2 is 8, what will our response be? What will y end up being? And then what if x1 ends up being 14 and x2 ends up being 5 and x1 ends up being 15 and x2 ends up being 3? What will the forecast be? So here we go. Equals the cell location where the intercept is. Dollar sign, what is it? K what? 32. Dollar sign K. Dollar sign 32. Plus or minus, we're doing forecast. Plus it is. The cell location where the first slope is. So dollar sign K, dollar sign 33 times cell location where the forecasted number we're going to use for X, which is 13. We could just put a 13 there or put C25. But don't put dollar signs because we want it to be C26 next. C25. Plus, here's the next one down. Dollar sign, the slope of the second one is K34. Dollar sign K, dollar sign 34 times our X2, which is going to be in D25. I don't want to use dollar signs there. Here's our first forecast. Now look at as our X is going up and our D is going down, our forecast, our Y responses are going down. So this number should be lower than 23. Sure, well, look at that, it's 23.3. Oh, I used an 8 instead of a 1 or a 2 or a 3, now I see it. So, but, here's the next one. What's gonna happen to this next number? Well, first of all, X is going from 13 to 14, so that means the slope of negative 0.51 is gonna reduce it by 0.51. Then, X2 is going from 8 to 5, so it's gonna also reduce it 0.17 because it's not 8 times 0.17, it's only 5 times 0.17. So this should be a lower number. Here we go, copy paste. 22.24882. The next one should also be lower by about that same exact amount. This one went down by 1.06, so this one will be 1.06. So the next forecast should be about 21.18? 21.37, oh, it's way up. 21.37. There you go. Can you do a multiple linear regression forecast if you were asked to use Excel to solve it? Yes? You can pick the cell locations wherever it is you put your output to put into the formulas also, right? All right. You've learned everything there is to learn today. Look at this. We also have a little bit of time. We have a little bit of time on our hands, right? You want a light lesson? Okay, hang on. This one is something that's okay. End of week 13, part 1. This class is almost over. We can't wait till it's done. We're gonna be on summer break.